All right, moving on to the 8.1 notes on arithmetic sequences. The objective for this lesson is that you should be able to identify arithmetic sequences and write explicit rules for the arithmetic sequence. All right, let's do some vocabulary. Sequence. A sequence is an ordered list of values that proceed within a pattern. Term of a sequence. It is each value in a sequence. In example number 1, we're being asked to find the next two terms for each sequence, then to describe the pattern. Okay, so for A, we have 1 is the first term, 3 is the second term, 5 is the third term, 7th is the fourth term, and the fifth term in the sequence is 9. So they're asking us to find the next two terms for each sequence. So we're trying to find the 6th and the 7th term. Well, to help us find that, we need to figure out what the pattern is. So as you can see, as we go from one term to the next, we have to add 2. Therefore, the next two terms in the sequence, the 6th and the 7th term, would be 11 and 13. Right? So the pattern is you have to add 2 to get to the next term. About part B, at 26, 21, 16, 11, and 6. What's the pattern? So the pattern here is we are subtracting 5 to get to the next term in the sequence. Therefore, the next two terms in the sequence are 1 and -4. Let's see if you can find the pattern in the next two sequences and what the next two terms are in each of those sequences. All right, for part C, you're going to add 3 to get to the next term. Therefore, 0 and 3 will be the next two terms in the sequence. And then for part D, the pattern is you need to subtract 6 to get to the next term. Therefore, -38 and -44 are the next two terms in the sequence. An arithmetic sequence is a special type of sequence formed by adding or subtracting the same number to each term. The common difference is the constant difference between any two consecutive terms of an arithmetic sequence. In example 2, we're asked to determine if the table represents an arithmetic sequence. If yes, then we want to determine the common difference. So you see in the top of the table tells us what term number we're at, and the actual value of a term is in the second row. So the first term is 15, the second term is 20, the third term is 25, and so on. So as we can see, to get from the value of the first term to the second term and the third term and so on, we need to add 5. So therefore, since it's a pattern of adding the same number over and over again, we're going to say yes, that it is an arithmetic sequence, and the common difference is adding 5. For part B, to get from the first term to the second term, it looks like we're going to need to subtract 4. However, when we get to the second term to the third term, it looks like we need to add 6. Because there is no common difference. All right, there is no pattern of adding or subtracting the same value over and over again. This is not an arithmetic sequence. So the common difference is not applicable because there is none. Now let's see what you can figure out from parts C and D. Now you notice at part C that the term number also goes into the negatives, which is possible. The negative third term is 8. The negative second term is 1. The negative 1 term is negative 6. The 0 term is negative 13. First term is negative 20. And the second term is negative 27. There is a pattern there, and we are subtracting 7 to get from one term to the next. And because there is that pattern of subtracting 7 each time, and we are saying yes, this is an arithmetic sequence. Same thing for part D. To get from the value of the first term to the second term and the third term and so on, there is a pattern. We need to add 8 every single time. So therefore, this is an arithmetic sequence. All right, so for example number 4, we are given this function rule, f of n equals 4 parentheses n minus 1 plus 3. And we're being asked to find the first 5 terms of the sequence. So in this example, n is going to represent the term number. So therefore, if we want to find the first term, meaning when n equals 1, okay, so again, n represents the term number. So we want to find the value of the first term. We are going to plug 1 in for n. So again, we are using function notation. And when we simplify the right side, we get 3. So the first term in the sequence is 3. To find the second term in the sequence, we're going to plug 2 in for n. So when n is equal to 2, we're looking for the second term in the sequence. So f of 2 equals 4 times 2 minus 1 plus 3. And then we get f of 2 equals 7, meaning the second term in the sequence has a value of 7. Now I want you to go ahead and find the third, fourth, and fifth terms in the sequence. Now for these 3, I did not show you all the work, but again, we are using that same function, plugging in 3 to represent the third term. So when we do that, and we do the computations on the right, we get the third term has a value of 11. The fourth term in the sequence is 15, and the fifth term in the sequence is equal to 19. Again, the way we got all this is by plugging in 3, 4, and 5 respectively in for n. We're being asked, do the terms of the sequence represent an arithmetic sequence? Yes. So what is the common difference? The common difference is plus 4. So here we're being asked to complete the table. So again, you see the first term is 3, second term is 7, and so on, all the way up to the fifth term, which is 19. But you're going to also notice that this table includes the 0 term. Again, to get the 0 term to be -1, all we're doing is plugging 0 in for n. Part D, we're being asked, would the function rule f of n equals 4n minus 1 also work for the same sequence? And our answer is going to be yes. As you can see here, if I plug in 0 in for n for this function rule, I get the term number of -1. When I plug 1 in for n, I also get f of 1 equals 3. And if I plug 5 in for n, I also get that fifth term is 19. So this function rule works for the same sequence. What would be helpful to write a function rule for sequence is to know the common difference and the value of the first term or any other term. So here is a sequence. Let's figure out the pattern and see if it's arithmetic. So we see to get from one term to the next, we need to add 6 every single time. And because of that, it is definitely arithmetic. Let's go ahead and complete that table. So we got our term numbers 1 through 10. And again, following the pattern of adding 6 each time, we're able to find the 5th through 10th term in the sequence. Now let's see if we can write an expression that can be used to determine the nth term of the sequence. So here's an expression that we can use. So now let's take apart the pieces of this expression. The 6 in this expression represents the common difference. That's the pattern. The 4 in this expression represents the first term value. And then the letter n represents the term number that we are trying to find. Let's see if this works in finding the 10th term of the sequence. So to find the 10th term in the sequence, we're going to plug 10 in for n. Simplify the parentheses to get 9. Then we're going to take that value and multiply by 6. Again, 6 is the common difference. So when we take 9 times the common difference of 6, we get 54. And then that plus 4 that we're adding is the first term. And that equals 58, which again is the 10th term in the sequence. So here's a formula we can use to write find the arithmetic sequence. F of n equals d times n minus 1 plus f of 1. Therefore, we're going to find the nth term in the sequence by taking the common difference, multiplying it by n minus 1, and we're going to add that first term in the sequence. So let's try this out with a couple examples below. All right, to write an explicit rule for part A, we first need to figure out the common difference, and that it's an arithmetic sequence. So we see we need to add 5. Also, we notice that the first term in the sequence is 12. Hey, that's all we need to write this explicit rule. Let's write that rule. F of n equals 5 times n minus 1 plus 12. That's the explicit rule. So to find the 100th term, I'm going to plug 100 in for n, do the math, and we get the 100th term has a value of 507. Next example, we see the common difference is minus 2, and the first term is a positive 32. So the explicit rule is f of n equals negative 2, parentheses n minus 1 plus 32. So the 100th term is negative 166. That's it for today. Move on to the 8-1 homework.